Good day, grade 9. Welcome to today's lesson. As you have seen, I have just typed my email address to all of you. You received, hopefully you received assessment from the school, assessment for technology. You are supposed to write that and submit it again to the to the school server. I'm just giving you my email address as backup, so you can try to submit on both the school server and the school drive, on the school drive, and my email address as well. Okay, it's a short assessment. I trust you to be able to go through it. Right. Today we are continuing with circuits. Grade 9, please take a good look at these circuits. It will benefit you as you study further in technology. You need to learn these circuits now in grade 9 and know them. I'm glad that you know now the relationship between voltage, current, and resistance. And we are continuing with that. The components that you are doing today is a collection of components that fall into resistors. So we basically are continuing with Ohm's law, just that we are doing circuits. All right. Now remember, I'll just recap on what we did yesterday. I have been doing these components with you, components and their symbols. This is very important for you to know and learn, because you will identify the symbols in your circuit diagrams. Okay, you'll identify the components by their symbols in the circuit diagrams. So it's very important that you recognize these symbols. Okay, you must know when you see a symbol what it represents. All right, and you must be able to draw your own circuit diagrams as well. Yesterday I showed you the LDR, and we said it is a resistor of which the resistance decreases when it is exposed to light of a higher intensity. Okay, you have LDRs that will behave like that, that will lower their resistance in the presence of light. But you also have resistors, the LDRs, that will have a higher resistance in the presence of light. Okay, now it can therefore be used to detect light and trigger warning devices in cases where light may cause problems. Warning devices, what do we mean by that? They're output devices. Please, just to show that you remember what you did yesterday, give me the name of the output that has sound. We can use that as a warning device. An output device that has sound. What do you call it? You know this from grade 7. Okay, what do you call it? A buzzer. So if you want to use this, very good, or alarm, good, yeah. So, can you see my screen? Can you see my screen? Okay, thank you. So, this is how you draw your LDR. It is a light-dependent resistor. So the resistance, I want you to understand high resistance and low resistance. High resistance, maximum resistance, or high resistance, okay? Resistance can be high and it can reach a maximum. So high resistance will be when the resistor is not, maximum resistance is when the resistor is not allowing current to flow through. So it just shuts down on current. That is maximum resistance. And then the resistance can be decreased at certain degrees, okay? So you have high resistance where there is little current that is allowed to flow. And you have low resistance. I'm back. I hope you can hear me. I was booted out. I don't know how. I think it is the network. I was discussing this light-dependent resistor. So this light-dependent resistor has a high resistance in the presence of light. So it doesn't allow a current to flow to the output when there is light, okay? And you can get another LDR that will have a low resistance in the presence of light. Okay, I'm sorry, Lenas, for the disturbance. Okay, let us look at a circuit with an LDR. There's our LDR there, right? Your light-dependent resistor, so those arrows should be light. Now, for some reason, we need the other resistors, okay, to reduce the amount, to control the amount of current that goes to the output. What is the output component here? What is the output component in this section? Thank you. It's the LED. Okay. So it means when there is high light intensity, this LED will not shine. But when there is darkness, this LED will shine because this is an LDR, a light-dependent resistor. So the resistance is high when there is light. Okay. Now, in this circuit, we also see other electronic components. I hope you can hear me. It looks like my internet is stable. I don't know. Right. You have resistor 1 there. Your resistor 1, resistor 2, 3, and 4 with different values. Okay. So when you go to FET, when you do electrical engineering or electrical technology in FET, then you will know why we have to put these values of resistors together with the LDR. Remember, the LDR is a resistor too, but it is not the only resistor in the circuit. There is another circuit I have shown you, you'll see it, where you just have the LDR and not the other resistors. But for a perfect circuit, you have to also include the transistor. There's the transistor, and then you have connected all these so that you can get an output there when the LDR is at its lowest resistance. Right. And then you have another circuit with a thermistor. You know, these are sensors. Grade 9. The LDR is a sensor. What does it sense? It senses light. The thermistor is a sensor. What does it sense? It senses heat. It's okay, Kai? No, now, this is a circuit with another sensor, namely the thermistor. Because a thermistor can sense temperature, we have a negative temperature coefficient thermistor, the NTC thermistor. This one is a sensor that is used for high temperature. It senses high temperature, the NTC thermistor. It senses heat. It is used for fire alarms. Very good, Kuba. Now, because it is a resistor, okay, its resistance will be lowered by the presence of high temperature. Then, when its resistance is lowered, then it allows current to flow through the other resistors to the LED, which is the output component. You can even add another output component because a fire alarm, it does have sound as well, okay? So you can add a buzzer, okay? So this is how you make up your fire alarm circuit. Then you have a capacitor. This is the graphic symbol for capacitor. A capacitor has its value measured in farads, okay? The farads, this one is a nanofarad capacitor. Here is the capacitor. A capacitor, it stores energy. It stores a charge, okay? So it has a time when it takes in the charge and we say it is charging. And there is a time when it releases the charge, then we say it is discharging, okay? So on one circuit, when you can check here, this is a single pole double throw circuit. So it divides this circuit into two, because when it is connected to this throw, to throw A, it is connected to another circuit. When although it is connected to a sub-circuit, okay, although it is part of the whole circuit, but this throw allows it to connect differently when it is and when it is discharging, okay? So that's why we have two LEDs here to make a signal of the two processes of the capacitor. The capacitor will have a process of charging, and when it is charging, one LED will be on. And it will have a process of discharging. And when it is discharging, the other LED will be on. So let us look at LED 1. Here is our power source. Our power source is a 6-volt battery. And when our capacitor is charging, okay, when our capacitor is charging, LED 1 will be on. And I think this switch will be closed, okay, so that current can flow. So LED 1 will be on, it is charging. And when it is discharging, LED 2 will be on, okay? When it is discharging, LED 2 will be on, okay? Then this circuit will be closed like that. Then the current is going to LED 2, okay? Then the capacitor is discharging, it's discharging the energy it is storing. Now, because the capacitor is such a component that can store a charge, you must be very careful when you are working with it, because capacitors, they explode, especially when they are connected wrongly. Now, these electronic components that we are working with, they have polarity. Polarity is when a capacitor has a positive and a negative terminal. You know, some components, they don't have a positive and a negative terminal. Like the LED, it has a positive and a negative terminal. The capacitor does have the positive and a negative terminal. So when you connect your circuits, you must connect it correctly. The positive must be on the positive and the negative must be on the negative, especially of the battery. The polarity starts from the battery, okay? You know that this is the positive of the battery and the darker one is the negative side of the battery. So when you connect your components which have polarity, you must be mindful of that. And besides, the colors of our wires, they show us the polarity. So you see, it is important that we use the correct color codes when we connect our circuits, so that the user, even you will know that because I have connected my red this side, that's my positive. Okay, my black is on this side, that will be my negative. So that when you connect other components, you can connect them to the correct polarity of your circuit, so that you don't hurt yourself. Let me tell you, grade 9, when you are connecting circuits, you must wear safety goggles, okay? Because if any component decides to explode, you only have one pair of eyes. We don't have spare eyes anywhere, okay? So you need to take care of your eyes, especially when working with these explosive components, right? So that is a capacitor. It charges and it discharges, okay? Right, and then you have a transistor. Right, this is a transistor. A transistor has a base, and it has a collector, and it has an emitter. Okay, this is an NPN transistor. You have different types of transistors, but in grade 9, we only work with NPN transistors. These transistors, they come in different shapes. There is an NPN transistor too, but it has a metal case here. I like that one with a metal case because we know that when I work with my grade 9s, when I'm using the one with a metal case, it has an ear. This part, this metal dish here, it has a part that has an ear, okay? And I know, although it's very easy to identify the base because you always know that the base is in the middle of these three legs. The middle one is the base. But it becomes very difficult for grade 9 to identify the collector or the emitter. So the metal case one has an ear, and we know that the ear will be the emitter. So if I want my grade 9s to identify the emitter, I tell them to look on the side where there's a little bit of an ear, a small ear, and then that will be the emitter. Right. Now, the transistor works as a switch. I hope it's not COVID, hey? The NPN transistor acts as if there is a switch between the collector and the emitter, which is a positive potential on the base of the transistor. And the switch is closed. So it is an electrically controlled switch. It acts as a switch in a circuit. There are other types of transistors. For example, PNP transistors that work a bit differently from NPN transistors, but you will only work with NPN transistors in grade 9. Okay. Now, there is a circuit with an LED. Let's go to these LEDs first. I brought these LEDs in different colors because yesterday, I remember, we were talking about different colors of LEDs. You know that in your gadgets, your TV or your cell phone and radio, you do see a little dot of a green light or a little dot of a red light. That is the LEDs. Okay, remember our gadgets have circuits inside them and they have LEDs too. Now, those LEDs come in different colors. They can even be orange, all right? Now, LEDs have polarity. As you can see, the legs are not equal. There is a long leg and a short leg, long leg and a short. We cannot see the legs of this one, but we know it is like this one. So, the shorter wire is the negative one. Okay, the positive is the longer one. The positive is long and the negative is short. Now, this is your LED. It emits light. The LED is a diode, right? Remember, we said yesterday the diode, it causes current to flow in one direction in the circuit. So you have to connect it correctly in the circuit. If you don't connect it correctly in the circuit, you will just find that you have a problem with your circuit. There's no current flow, only to find that your LED or your diode is wrongly connected. The polarity is wrongly connected. So you need to know which side is the positive and which side is the negative. The positive side is called the anode, and the negative side is called the cathode. So the cathode is short and the anode is long. Okay? The anode that you're going to connect to your red wire is long. The cathode that you're going to connect to your black wire is the shorter one. Then you have a correct connection of the LED. Let's look at a circuit with an LED. You have a 4.5 volts battery, okay? And you have your resistor there, and you have your LED there. Now, the polarity of the LED. Now, this is the LED. Okay, where's the LED? This is the LED. You have, this side is called the anode, and this side is called the cathode. This side is negative. You are going to connect it to your black wire. This side is positive. You are going to connect it to your red wire in your circuit. So, we are going to look at the circuit now. This side is the anode and this side is the cathode. It is connected to the negative side. The cathode must be connected to the negative side of the circuit. And this is the cathode connected to the positive side. Okay? As you can see, this is the anode, this is the cathode. The anode is positive, the cathode is negative. So you can check the connection. It is correct. Okay? Now, this is a touch circuit. Okay? Now, when you look at this circuit, it also has a transistor. The transistor will be connected to the LED on the collector part. And the emitter will be connected to this 100 ohm resistor. Okay? Why do we have to put resistors in circuits? Remember, other electronic components are very sensitive to current, so they can burn out. They can burn. So you need to control the amount of current that goes into those components. So that's why we have to put resistors. Now, this is a touch switch, okay? It's a touch circuit. I told you that in grade 9, we learn about sensors. One, the sensors that we have learned so far is the LDR, the light-dependent resistor. That's the LDR is a sensor component. And we have a thermistor. You have seen the thermistor circuit. And the thermistor itself is a sensor component because it senses temperature. And then we have another sensor, a touch sensor, okay? A circuit which is going to be activated by touch. So this is such a circuit. So when you touch here, the LED will be activated. It's an output component. It will show that you have, this circuit has sensed something. So you don't have a component for that one. It's just your arrangement of leads in your circuits. That will make your circuit sensitive to touch. All right. This is how you connect your LDR in a circuit. This is a very simple circuit. without a resistor. You have your power source connected like that of 6 volts, and you have your LDR there and your buzzer. So this will give you just perpetual sound here as long as it's connected, because there's no switch to it. The only switch can be light or darkness. Right, let's just talk about our sensors. Right. This is a variable resistor, okay? They also call it a potentiometer. Right. This variable resistor will give resistance at different degrees, just like on your stove. Your stove can be adjusted to 1, 2, 3, 4, 5, 6. Some others have 8, I don't know. But when the stove is adjusted at 1, when this variable resistor is adjusted to 1, it has a high resistance because heat is very low. It doesn't allow the flow of current from the plug of the stove. So the heat on the stove plate will be low, okay? Because the resistance is high. So the units on this variable resistor, they are the inverse of resistance. They are the opposite of resistance. When the unit is low, the resistance is high. When your stove is at 1, the resistance is high. When your stove is at 0, the resistance is maximum because the stove is off. So the resistance is maximum. No current is allowed to flow through. Okay? I hope you understand the operation of the variable resistor. Same application in a radio, okay? When your volume is low, the resistance of this variable resistor is high, okay? And as you increase the units of the volume of your radio, as you increase them, the resistance is lowering. Okay, so that is why your volume is high when you increase. Oh my God. Okay. When you increase the units of the potentiometer, what happens? The resistance lowers. Because the resistance lowers, you get a higher flow of current into your circuit. So you get a higher volume when you lower the resistance of this variable resistor. Right. So because we are doing sensors, we often use the potentiometer. Okay, this type of circuit uses the sensor circuit. It uses an input sensor in combination with a transistor to switch the output device on or off automatically, depending on the measurement of something by the input sensor circuit, since one circuit controls another circuit. In the case where a transistor is used as a sensor, with a sensor, such as an LDR, the base emitter current controls the larger collector emitter current. So you need a transistor in such a circuit, in a sensor circuit. You need a transistor. We explained that the transistor can work as a switch. It can do an on and off function in the circuit. If a decrease in resistance, a decrease in resistance will be controlled by this variable resistor. If a decrease in resistance of the input sensor should switch on the output device, maybe the buzzer or the LED, then resistor 2 and the input sensor should be arranged as illustrated below. I will show you the circuit just now. If an increase in resistance of the input sensor should switch on the output device, if you increase here, how do you increase resistance? You lower the units of your variable resistor. They are increasing resistance. If an increase in resistance of the input sensor should switch on the output device, maybe the buzzer goes off or the LED lights, then resistor 2 and the input sensor should be arranged in the opposite way of the illustration in the circuit we are going to share now. The variable resistor is used as a switch here, this one. Okay, let's look at the circuit. There is your input sensor and your output device. There could be a thermistor, an LDR here, okay? Because we are doing 3 sensors here. You could have a thermistor or an LDR here, okay? And then you could have an output device here, an LED or a buzzer. Now, this, what is this? This is your variable resistor. Now, your variable resistor is going to control resistance. Okay? This variable resistor. When it is adjusted to a low unit, that is a high resistance. Okay? Then you will detect the resistance by the action of the output device here, be it a buzzer or an LED. It will be controlled by the adjustment of this. You do get other variable resistors. They look different, but their function is the same. Okay? Components are like that. You can go into an electronics shop and ask for a variable resistor. They will give you something that looks almost like a buzzer, okay? Or that looks almost like a capacitor. You do get that variable resistor that you adjust with a screwdriver, a small screwdriver, okay? But I like this one because we all know this one. When the switch of your stove breaks, what you see there, when that plastic cover of your stove switch breaks, you see this, there's a variable resistor. Okay, I like this one because it's very easy to identify. Right, what you need for the sensor circuit, because in grade 9 you are doing sensors, I would very much love for you to connect these circuits. My only problem is that you have to do it under very strict supervision and safety rules. Right. In this, you need a battery consisting of 6 cells. That's a 9V battery. Okay. An input sensor to measure the temperature. Input sensor here, maybe a thermistor, a variable resistor to set the temperature at which the alarm should go off. An output device to make noise when it gets too hot, and a transistor to switch the output device on when it gets too hot. I think you understand now the role of these components, okay? In your workbooks, you do have a sensor circuit, which you will need to connect, like the fire alarm one. I like the fire alarm one. So I like the instruction in your workbook. It says, set your variable resistor at its lowest resistance, okay? It means you are going to set this variable resistor at the maximum setting, okay? If the maximum is 6, you're going to put it on 6, okay? It doesn't have units. You just know that when you're switching it clockwise, it is going higher and higher. When you're switching it anti-clockwise, then you're going to a higher resistance. When you're switching it clockwise, you're going to a lower resistance, okay? So this is the basis, the basic circuit for your sensors, okay? Let us end it right here, grade 9, because this sensor circuit, it is the practical assessment task for term 3 in grade 9, the sensor circuit, okay? You must not pass grade 9 technology without having studied the sensor circuit. And you must know the components that go into it and how they relate. What is the relationship of these components? You must know them. Because if you continue with electrical technology in FET, you need to have this as your basic knowledge. Thank you very much, grade 9. All the best with your assessment and have a lovely evening. Thank you. Bye.